So we'll look at this question. Shortest way to form string. A subsequence of a string is a new string that is formed from the original string by deleting some can be none of characters without disturbing the relative positions of the remaining characters, i.e. ACE is a subsequence of A, B, C, D, E, so ACE, while AEC is not because the order matters, right? You can't get AEC from the order of A, B, C, D, E. You can only get ACE. Alright, so given two strings, source and target, return the minimum number of subsequence of source such that their concatenations equals target. If the task is impossible, then return -1. Okay, so that's pretty straightforward, and let's look at the example. The first example, so source ABC and target is ABCBC. The output is 2. Why? Because, let's see. So we want to form this, right? ABC, ABC. And we already know we have the ABC. So the first ABC can be formed directly from the source, which is 1. And the BC can be formed from the BC here, while deleting A. Or you can say ignoring or neglecting A. So yeah, here's explanation. So formed by ABC and BC. So 1 plus 1 is 2, and the output is 2. The second one, ABC, target is AC, ACD, BC, -1, which means we can't form it from the subsequence. Why? Okay, it's also pretty straightforward, to be honest, because in this condition, we don't have D, right? We don't have D in the source, but there's a D, so how come could you get a D? There is no way. So that's why it's impossible, and the output is -1. The third example, so source XYZ, target ZY, XZ. Okay, so check. Is there something that is not appeared in source while it's in the target? No, right? So everything is X, Y, Z, and they're all in the source. But the output is 3, right? So first, we want to see XZ, okay? So how could you form XZ? It's actually coming from X and Z while deleting Y. So that's the first one. Okay, after XZ, Y. This Y. How could we get Y? Well, since we are already finished the first subsequence, so we need to get from the beginning again. And we don't need X here. So we only need Y while deleting X and Z. So the second one is Y. Okay, so the last two, X and Z. So how could you get X and Z? Well, it's just like deleting Y, right? So it's the same as the first one. So there are three, kind of subsequences that we need to form the target. All right. So what's the kind of high-level idea for this, coding problem? Well, as we said, we maybe need to consider the edge case in the beginning. So what are the scenarios that we don't really need to we don't want to handle later, which means the edge cases that we want to neglect or return -1, right? Yeah. So -1, right? We want to return -1 for the cases that are invalid. So what are those kind of cases? Well, it's actually pretty straightforward because if there is some or there are some elements in target that are not appeared in source, then what should we do? We simply return -1. That's the case that we just return -1 and no further, for we will not go to any further steps. Okay, so the second one is, well, do we have any other edge cases? What about, like, say, the source or the targets have some issues? Let's say the length of source is, kind of 0, or the length of target is 0. Well, I believe in this kind of scenario, we can we can do like say 2 lines to handle this case, but I don't think there are gonna be this kind of um, test cases for this question. So I'll just neglect this one. Okay, so that's gonna be the next steps is gonna be the real thing, right? The real thing is coming. So how should we do to get the minimum number of subsequences? Well, it's actually not that hard. So as we see, the source is a single string, while everything, since there's a condition here, um, it has to be formed in relative positions, which means we can just like go through from the first letter to the last letter of source and check, let's say, if this one is equal to this one. If they're the same, then okay, we go to the next one. We check if this is equal to this. Okay, so they're not the same. Then we just neglect this one and go into the next one, C, and check if they're the same. Okay, they are the same. All right, then we go to the next. So what's the next after C? Then it's gonna be A, right? So we're kind of just using the source repeatedly from beginning to the end and then coming to the beginning. It's like a cycle. And then we use it to check the targets, one by one. And after C, right? After C, if we had some letters that equal to C, and after C, we need to, when we want to go back again from the beginning A, we need to update the count because we're like using another source again. So we're doing it from the beginning. And that's the kind of core idea for this. And we need to design a algorithm that is efficient and also straightforward to see. But before that, let's just implement the impossible check, the invalid checkings. So here we'll use a function called isSubset. So if not set source, okay, actually target. If not set target dot is subset of source of actually set of source, then we return -1. What's the meaning here? So if the set of target, right? So the set of target meaning we only get the unique letters. So for here, let's say here, then it's gonna be ABC. So the set of target is a subset of set sources. So if everything here, the set of target is the subset of the set of sources, which means if that's true, then there must be a way to form this target. The target must be formed, or let's say there must be a way to form the source from the subsequences of target. But if that's not the case, then we don't have any other ways to do that. So we can't form it, so return -1 directly. All right, so that's the edge case handling. And as I just said, in the example, we compare AA, B, and C. So this idea is what we call two pointers. What are the two pointers, right? So the two pointers means there are at least two pointers. So what are the two pointers? The first pointer is coming from the source. So let's just name it I equal to 0. The second pointer is also coming from the beginning of target is J equal to 0. And keep in mind, we also need to keep track of the count, which is something we want to return at the end. So that's the initialization of these variables. And okay, so let's go to the real algorithm. So what's the algorithm gonna do, right? So in the outer loop, we want to know the condition that we switch to a new subsequence, meaning switch to another source after, like, let's say we used up this ABC, right? ABC is used up, and then we want to go again using the source again. So what's that gonna be? Right? So we probably want to design a while loop, right? Because we don't have, it's very hard to design a for loop in this case because we don't really know how many times we want to iterate. And a while loop is gonna be, what's the condition? So the condition is gonna be j less than length of what? Length of target. Meaning, if we didn't reach to the end, then we have to keep up. We still have to looping until the end, until j reach to the end of the target. At that point, we know we are finished. So that's the first condition. And here, count plus 1, because you'll see in this loop what we're gonna do. So the outer loop is the real, like, handling, like seeing if we need to really stop the entire program and return. In the inner loop is we want to check if, like why we have a count plus 1, right? Count plus 1 means we're using another source string. So what's the condition to get another source string is when we used up, right? So how do we know we used up the source string already? So I minus length of the source, right? And j is less than length of the target. Since we want to, really handling the error for, we don't really want any errors and out of bounds things, so that's why we also have it in the end. But the real thing, the real meat, the real core is really I less than length of source. So if they still satisfy the condition, we don't want to use another source again. Okay, so what's going to be the inside, right? We want to check, as we said, we need to check, are they the same? Are they the same, right? So if source at I is equal to target at j, then what should we do? If these two things, these two letters are exactly the same, then j plus 1, right? Because if they're the same, then we don't really need to consider this letter. We just go to the next one. But for I, actually, we don't really need, we also need the I to be updated, but we update here. Why? Because even if they're not the same, I still has to be updated, right? I still has to go to next. Otherwise, how can we get another one to compare it with the existing, target letter at this j position? So if we don't update I, then it's gonna be comparing this to, forever, which doesn't make any sense. So we need to update I no matter the two letters are the same or not. Okay, so what's next, right? What's next? So that's the thing for updates, for like comparing for each like source. But after comparing the source, what should we do? There are two things. Okay, so if j is equal to the length of target, then we just return count. Otherwise, we just need to update I from the beginning. Okay. So that's the while loop, right? Why should we have the if j if it's equal to length of target, well, well, actually, I think it may work, but let's try. Okay. Okay, it actually works. So, if the source, if the j is equal to the length of target, so we can check it directly here and we return. But if it's not the same, so if it's still not to the target, then we still have to go to another loop and we need to make I to 0 again and coming using the while loop to check again. So that's the idea. And what's the complexity? So the complexity for the running time in the worst case is going to be big O of n squared. If, let's say ABC and for source and target is EDF, then it's really going to be, the length of source times the length of target, which is going to be n squared. But for the space, it's still going to be big O of 1 because, we only have several variables. We only updated them and keep track of them. So it's still going to be big O of 1. All right, hope it helped. Thank you.